So in this video, I'll be going through question 2 of the 2023 prelim paper. So when setting the question 2, we wanted to present our student with two main challenges. Number one is that we didn't provide them any diagram like the cartoon that I draw on the right. Instead, we wanted them to be aware that in this one-dimensional motion, the object, which is the rocket here, actually goes vertically upwards and falls back down. And why is this a challenge? Because when the motion change from upward to downward, it means that the direction of your air resistance will also change. Because as we know, the direction of air resistance will always oppose the direction of motion. So this is the first challenge that we want to include in our answer, in our question. The second challenge that we want to present our student is that instead of giving them a typical distance time graph or velocity time graph, we wanted to give them an acceleration time graph to actually check whether they are comfortable reading the acceleration directly from the graph. So for example, if I were to ask you what happened at time equals to 4 seconds, will the student be able to actually read from the graph that at time t equals to 4, the acceleration correspondingly would be 40 meters per second square. The other challenge that we embedded here when presenting an acceleration time graph is that we want to see whether students are aware that a equals to 10 is an indication of something special. So for example, when an object is undergoing free fall, you will expect an acceleration of 10 meters per second square. So because of that, when you see that a equals to 10, it actually means something, right? What does free fall mean? We also want to check the understanding from students, whether they understand what free fall means, because a lot of students just think that, oh, free fall simply means that there is no air resistance. This is a very sweeping statement that most students will share with us when we ask them what is free fall. But in truth, free fall actually means that the weight is the only force acting on the object. Okay, some of you at this point in time may be asking, what do you mean when an object is undergoing free fall, the weight is the only force acting on the object? Well, if you look at Newton's second law, so Newton's second law gives this equation, F net equals to mass times acceleration, right? What if the weight is the only force that is acting on an object? Then my left hand side will turn into W, and we all know that W is given by mg. So if you look at the mathematics, eventually the m will get cancelled away, and you will be able to arrive at a equals to g, which is 10 in this case. So technically speaking, when we talk about free fall, it's not so much on no air resistance, but it's actually saying that the weight becomes the only force acting on the object. Or to be even more precise, we have to say that when the object is undergoing free fall, then your F net will become the weight only. Okay, so let's look at the question. So first of all, I try to check whether students have this awareness of unit. So we ask them to find the weight, and if you are lagging in terms of awareness of unit, you may substitute 400g directly into the equation, which is wrong. When you are using F equals to mg, you need to make sure that the mass is actually converted to kg, and you'll be able to find that your weight is 4.0 Newton, 2SF. Then for part B, it is actually a challenging question, and many of our students is actually just trying their best. We appreciate that you didn't leave it blank, but we also want to share with you, don't panic. You see in this working shown by this student, you can see that he's trying all sorts of things. For example, here you can see that he's trying to turn the 400 gram into kg, but strangely, he multiplied this into 20. I don't see why you do 20. So earlier on, I share with you that I want to check whether students are comfortable reading directly from the graph, right? So here we give the hint, time equals to 4. So you should be reading the information from here, time equals to 4, what is the acceleration? But here you can see that at time equals to 4, A equals to 14, but you can see that the student actually substitute 20. I think this is because he wanted to find the acceleration at the start, which puzzles me because the question is asking about t equals to 4. Fortunately, after some attempt, you can see that he changes it to this. He managed to find the net force. Then after that, I don't know what is this 8.5.6. I can only assume that this is minus. So you can see that from this working, the student is just panicking and just trying all sorts of things without proper presentation. So my question to students that does this is that you can take shortcut when your mind is clear because you know exactly what you're going for, how you're going. Clearly from this working, we can see that the student had no idea what to find, what is the approach. The student is just trying. And in cases like that, it is even more important that you follow a systematic approach, right? Something that you have tried many times in your homework and you just try this approach and see where it leads you, right? So because of that, you need to stay calm and you follow what is taught to you. So what is taught to you? Well, in our homework, we always practice these two equations, right? Newton's second law, definition of F net. So use this, right? In case where when you're under stress, you have no idea what to do, yeah, then refer to something that you have tried and that you know you won't get it wrong. So just write down these two, right? And see what you get. So time equals to 4. We need to know at time equals to 4, is the rocket going up or is the rocket going down? Because if the rocket is going up, you will get air resistance acting in another direction. If it's going up, it is another direction, right? So looking at here, we have very little hint except this statement. The downward direction of the motion is represented by a positive value. So this 14 is a positive value, meaning that the acceleration is still downward. So if we construct our free body diagram, so let's let this be our rocket ship. We know that the acceleration is downward at 14 meter per second square. What would be the forces acting on it? Definitely going to be the weight. Then we ask ourselves if the air resistance is acting against weight, then I would have an acceleration definitely lesser than 10, right? So if I have a downward acceleration that's more than 10, it would only mean that my air resistance must be also acting downwards, right? Then I would have a acceleration that is more than 10. So once I establish this, there's no other forces acting on it because it is in mid-air. Certainly there will be no more upward force acting on it. There's nothing pushing it up, right? The object is slowing down, right? So because of that, it makes sense. It seems all the forces have checked out. So now I do substitution, right? I don't know what's F net, so I don't stress myself. I just write down what I know. M, I know it is now 0.4. Acceleration, we have gotten it from the graph. Then here, I don't know what's F net. What are the sum of forces? There are only two forces. So W plus my air resistance. Notice that I leave a gap over here just in case when I check the direction, I may need to add a negative sign in front. But in this case, since the question says downward is the positive, both forces are downward, I will leave it as it is. So I can do a quick calculation. 0.4 times 14 will give you a certain value. it will give you how much? Let me take a quick look of my calculator. Right, 14 times 0.4, that will give you 5.6. Right, then now I know my F net is 5.6. My W I have found earlier, which is 4. Now I can find my air resistance, which is 5.6 minus 4. That will give you 1.6. Okay, so with this approach, I am able to find what is my air resistance. That should be 1.6 Newton.